I was making a really simple 3D engine only supporting points, when I ran into the problem of having to make a sphere. I had to figure out a way to plot an even distribution of points on the surface of a sphere. I settled with a parametric function that would draw a curve between each point, which unbeknownst to me would later allow me to graph spherical points in any dimension. Here we have a unit sphere, and we can inscribe this sphere with a ring moving around it like this. The ring has a radius of the sine of its angle, and a height of the cosine of its angle. Since this ring is where each point will go, we can imagine a cursor frequently spinning around this ring to cycle through its angles as the height cycles less frequently. If we draw a parametric function from the tip of that cursor, we are left with this. The function works by first taking our formula for a circle and making it spin more frequently by multiplying t with a constant, k. Then we multiply the radius of our circle with sine of t, moving it inside the parentheses. Lastly, we simply have to add a new coordinate which will be the cosine of t. This is how it looks in action, not perfect, but gets the job done. This however made me think. If we now have a function that cycles through all spherical 3D points, what stops me from using that to cycle through all those points while moving through the fourth dimension? The radius of the sphere would simply depend on how far we are in the fourth dimension. So I made a new function that takes the previous one that graphed our sphere, but using k times t as its argument and multiplying the function with sine of t and finally adding a new dimension which will be the cosine of t. Here is what our sphere will look like as we travel through the fourth dimension, the radius shrinking as we travel further. The formula we used to create this is a recursive formula for n dimensions. The first iteration of this function is just a point with a single coordinate, 1. This makes sense as it is the only value that has a unit distance from the center in 1 dimensions, along with -1. This formula makes our function cycle through its dimensions with differing frequencies to give a better distribution of our points, and we know that if the distance of the previous function is fixed as 1, then the distance of our current one will be that of a 2D point with coordinates sine and cosine of t, which of course is equal to 1, which proves that all our points are exactly at a unit distance from the center. Thank you for watching. Hopefully you found this interesting, and please leave a comment if you have any other ideas or disagree with what I said. See you next time.